Hi, my name is Ryan from Usher Labs, and I'm here today to introduce to you the Cross-Chain Asset Management Protocol, or CAMP for short. Now, the reason why the team at Usher Labs decided to work on this is because we found that there was just simply no way to aggregate liquidity across different blockchains into an environment that could be powered by data and keep that entire process non-custodial. What the CAMP aims to do is deliver just that. The inspiration for this came from the fact that we had a referral marketing solution we were developing initially, and that required a mechanism for allowing advertisers to deposit whatever assets they wanted, and then for data to redistribute those assets accordingly. So let's talk a bit more about who our target users are. Well, we're approaching developers within the ecosystem to develop custom modules that register into this CAMP protocol. Now, what a custom module does is it allows for investors to deposit across any existing integrated blockchain and then assign that liquidity once it has been deposited to that custom module. Then that custom module can use user inputs or custom data that occurs off chain and is powered by a data protocol to impact how the assets that have been assigned to that module are reallocated. So for example, if X, Y, and Z events happen on these foreign blockchains, that data can be powered or can be ingested via a data protocol into this custom module that a developer creates in order to reallocate those assets accordingly based on that data. Right, so this is a core problem that we were facing that we're trying to introduce. And one of the core fundamental reasons we're developing on the internet computer to do this is because of this functionality around not only oracles, but threshold signature schemes and allowing for signatures to power access to foreign contracts so long as there is that ECDSA crypto primitive compatibility, right? So we've identified a way, for example, to leverage existing liquidity that resides within platforms like Uniswap or 1inch or different other AMMs in order to facilitate cross-chain swaps through this protocol. Furthermore, this protocol could be leveraged for powering real-world assets or enabling swaps between the chain key Bitcoin asset and off-chain Ethereum or layer 2 assets as well. So we think the potential is big, except we're looking for developers to partner up with in order to enhance and realize that vision. Let's dive into the architecture and a walkthrough of the code. Cheers. Hey, we're back with the next section of the video, which is a walkthrough of a simplified architecture that demonstrates how the platform works. So you can see here we have a depositor and we have a user. The depositor would be an investor. This left-hand side of the protocol is abstracted away from the developer, who we're looking for, right? The developer would be creating this data collection canister. Okay, so we've set the actual users or actors in this architecture. What a depositor does is deposit some assets in any one of our locker contracts deployed across foreign blockchains. Then those contracts emit events, and through a data protocol, a bespoke data protocol, that data is ingested into the internet computer data collection canister that's relevant to that blockchain. What that does is it basically unifies all of that liquidity into this remittance canister. So we have a single balance map to manage where assets are allocated between these foreign blockchains. In that deposit process, there is an identifier that is included. And that identifier represents the data collection canister that the developer has registered. Okay, so now we have a process where a programmatic environment powered by data can reallocate liquidity that's been aggregated across foreign blockchains. I hope that gives you a good, quick overview of how assets come in, a very quick process about withdrawing. In order for a depositor to withdraw, what they do is they effectively ask the remittance canister for a key, a signature, that they can then forward to a locker contract in order for that key to be verified and for those funds to be withdrawn. Now I'm going to jump over to Alex, who has been very hands-on with this protocol and who will guide you through the actual code base.
Hi, for this next section, I'm going to be giving a walkthrough of the canister code. So we have the canisters running here. So right here, I have the terminal of the canister. So this can essentially be toggled by running dfx start or dfx stop. So it's running right now, so that's what I have here. So all this we have here just outputs essentially from the running canister, so in case there's an error or just some login. So that's what we have typically here. So we just have some information login here. So I'm going to start by the explain the basic command, which we have is get available balance. So how we locate the code responsible for this particular call is we look for this dfx canister call is basically just the generic command. So this is the name of the canister we want to call, and to find out we just come to the source file and we can see the name of the canister here, which is the remittance canister. And to access the particular functions, we can find them under source, then lib.rs. So lib.rs is the entry points for basically every canister. So then we can then look for the get available balance function. And we can see it here. So what this does essentially is it takes in several parameters, which we provide here. And then it checks, it calls this function, which you can then trace into the remittance package, get available balance. So what we'll do is go to the remittance module, then find the get available balance method here. And we can see all it does essentially is it gets this variable, then it queries the mapping using these keys, then it gets a response and returns that response. So that response is then going to be returned to us via the command line, which is essentially just the mapping of all these parameters to the total balance of the user. So that is how we trace functions. So we also have another important function which was the remit function. So we can see it in the remittance canister. So we come to remittance canister, we check the lib.rs file, and then we look for the remit function. And then in the remit function, we can actually see the code responsible for generating all the important parameters we use to claim our tokens from the smart contracts. Yes, and this is the signature, which is basically an ECDSA signature, which we generate from here. We generate it by using the Ethereum module, which then calls the sign message function on this message hash, which is essentially a hash of several parameters, which you have here, the nonce, the amount, and the address. So once we have the response, we just return it, which is essentially the hash, signature, nonce, and amount. Then we then use these parameters to facilitate a withdrawal from the smart contracts.
Now that was just a taste of what Alex has actually created with regard to a code walkthrough and a full product demo. If you're interested in learning more about the CAMP, please be sure to check out his videos, which are in the README file for the CAMP's repository. Furthermore, we have a bunch of outline around our roadmap and how you can get involved in helping us develop this out. So if you're excited about it, please jump into our Discord, check out the README, check out the repository, and let's keep in touch.